Alright, so problem number 3, count substrings that can be rearranged to contain a string part 1. Basically, we are given a word and we are given a word, another word too, and we are asked to find all the substrings in which we can arrange any of its letters such that word 2 becomes a prefix. Alright, so this is a good example to explain it. Alright, so this is the string and we are looking for A, B, C as the word 2. So this is one substring, this is another substring, this is another substring, this is another substring. So there can be more letters than required, that is fine, but there has to be minimum number of letters that forms word 2. So that is the trick here. There are two ways to solve this problem. I'm going to show the each of the way for each of the problem part 1 and part 2. So the first is basically uh, keeping track of the frequency of every letter at every point. Alright, so it's essentially forming a prefix. Alright, so this is the number of letters that we have in word 2. So in essence we are going to have all the letters A, B, C to Z. Others will be 0 which are absent, but the ones that are present will be 1. So here it will be 1, this will be Z1, since it will continue, it's a prefix, right? So it will continue, this will be 2, 2, 2. This will be 0, 1, 1, 1, 2, 2. This will be 0, 0, 1, 1, 1, 2. Alright. So this is the whole setup. This is the word 1, this is the word 2, and these are the prefixes. Actually, I forgot to mention, my bad, I forgot to, since prefix has this initial array. Alright, so this is the initial array at this particular index. What I'm looking for is 111. That's what I'm looking for, right? So that 111, if cancelled from 000, we'll still have 111, which is the frequency for word 2. So I'm essentially looking for 111, which will give me index 2. And from index 2, it will always be valid because it's a prefix. So this will be monotonically increasing and we won't lose any value as we move forward. So it will always be valid till the last index. So the number of substrings that I will form will be 5 minus 2 plus 1. Similarly for B, I will look out for 211, right? Basically, this incremented by the frequencies of word 2. So 2, 1, 1 for this particular index will be found here, which will be index 3. So which is nothing but this will be 4, this will be 3. What are those three strings? Well, this is 1, sorry, this is 1, 2, 3. Alright. Similarly, for C, I will have 5 minus 2 plus 1, which is 2. And finally, for this one, I will have 5 minus 5 plus 1 is equal to 1. So this will in total give me 10 substrings, which is my answer. Alright. Now the question comes to find. So I will have a vector of called to search. So that will be the one that I need to search. So at this particular index, that value will be 111. At this particular index, that will be value will be 1 plus 1 2. Sorry, 1 plus 1 2, 1 plus 0 1, 1 plus 0 1. So I'm essentially adding this for every prefix that I have and trying to search here. And since this is a monotonically increasing values of prefix, I can do a binary search on that. So on this index, I'll do a binary search. Suppose this gives me D this, then I will check where to go, left or right. Since this is monotonically increasing, I will you know, find this in logarithmic time, and that's how we are going to solve this. Let me reset it so that we can do it again. Let me copy this. I will have a vector of string, sorry, not string, int, which will be prefix frequency, and this will be of length m, which is word1 dot length, and n will be word2 dot length, m comma vector of int a to z, so 26 letters to keep track of. I will create a to search frequency, which will be a vector of int of 26 size, initially 0, which will iterate over word 2, and this will be created. So to search of word, let me just this thing, n minus a plus plus. So I will traverse over word 1, actually m, alright, and I do a binary search, which I will keep on adding here. So this will be long plus equal to, this will be provided from the binary search, m minus index will give me the answer. So m minus binary search will give me the answer, and the next time my index will be, or actually my prefix will be, prefix to search will be what? Will be this added with the current letter that we have used. So I can build the to search every time I do the binary search, but that is not necessary, and that will give me TLE. So essentially I have to do it, kind of sliding window way. As I go, I will keep on adding this word 1 of I to this. Fine. This is what I'm searching. On what? I'm searching this on prefix frequency of I, Yeah, and finally, what is the starting index? This is the starting index, and this is good to go. I will return my answer here. What is the binary search function? I create that here. Alright, so this is a vector that I am searching for, and this is the vector prefix, comma, end start. What is my end? End is nothing but m, right? So essentially this is my end, or m minus 1 is my end, so I'll pass m here, which is, or actually m minus 1, which is my end. My answer will be initially, since I'm trying to minimize, right? So I'm trying to find all the substrings. So essentially I'm trying to minimize, right? Minimize this task so that I have all the substrings that is possible. So my start will be my answer first. Sorry, my end will be my answer so that I can minimize. Actually, let's see. Since I'm going to return, if it's an invalid case, then my answer will never modify, right? So this should be 0. When will this be 0? This will be 0 when this will be m. When will this be m? When answer will be m. And answer will be n plus 1 because I'm passing m minus 1, right? So that's why I did this. And now let's see the binary search. While start is less than equal to end, I will get the mid like this, and I will check if is valid. So this is the function I'll create, which will take toSearch, which will take prefix of actually I'll pass the entire prefix frequency, not just that frequency. Yeah, so I'm sorry, I have to pass the entire frequency prefix frequency. Alright, and at this point I will be checking toSearch with prefix of mid plus 1. Why plus 1? Because we have this initial block of empty array, right? If you actually, my bad, I should increase my size. And form the prefix as well, right? So I forgot the prefix frequency itself. I'm sorry. Let's create it. Auto end word 1 prefix frequency of I. I'm sorry. I should wait, otherwise it will be a problem. Or will it be? Actually, I can do it this way: prefix frequency dot pushback prefix frequency dot back. Alright. And finally, frequency dot back of n minus a plus plus. Alright, so this is basically forming the prefix frequency, and here I will pass nothing else. If this is valid, then I'll go towards the left. Start, sorry, end will be mid minus 1, and my answer will modify to mid, otherwise I will go towards right. And finally forming this boolean is valid, where I will pass the search vector along with the vector that I am looking for, the vector in which I am looking for the value. I will iterate over 26 letters, and at this point I will check to search of I. If it's smaller than, sorry, if it's if it's smaller than prefix of I. Let's think about it. Prefix of I should have larger values, so it doesn't matter. But if prefix of I is a smaller value than search, then it's a problem, and I'll return false here itself. Otherwise, I'll return true. Alright, so this, I'm sorry, this should be all for this problem. Let's see if this works. Okay, so actually I did a big mistake here. I should have been careful. So prefix frequency, let me not initialize it here, right? And let me add the initial value to be this source frequency. It doesn't have to do anything with this. In terms of readability, it is very bad, but it's just easier to, it's just few less lines of code. And at this point, prefix frequency dot back, that's fine. And I guess this is it. Let's see if this works. Yeah, this works, and let me add that, submit it. And time complexity will be, since we are doing a binary search, this will be, by the way, O of n. This will be O of m. This is nothing but, for every iteration I'm doing a binary search, so it's essentially my overall time complexity m into, this is m, this is n, log of for every binary search there is a 26 comparison, so that's fine, that's a constant. But there is a binary search, so this is basically m log m if I'm not wrong, and space will be O of m into 26. Actually, O of m plus n will be the space complexity, and O of m log m will be the time complexity. So now let's move on to the fourth problem, which is basically exactly same, but we are given that we have to do it in linear time complexity, which is straightforward in terms of intuition, very straightforward. So let me take this example. So if I do a sliding window technique, I will need to entirely cover all the characters from word 2. So this will be the point where I cover the entire frequency of word 2. Anything after that from that point will be included, right? So this will give me 4, right? 1, 2, 3, 4. This will give me 3, this will give me 2, this will give me 1. Alright, so that is my answer. Okay, so that can be solved using every using sliding window. This will be I. For every I will push j as much as I can. So my j will be at this point here. So I'll do a j minus I, add it to my answer, and lose I. I'll push j as much as I can. This is the this is the most I can. I will add it to my answer, 3 j minus I, and I will lose I, lose the previous I. Push j, add to my answer, lose I, and finally push j, I can't, add it to my answer. But at this point, how much I need to push j, that is determined using the frequency of word 2. So I will have a frequency called present, missing, right? So initially all the characters of word 2 will be in missing. As I keep on as I keep on growing my sliding window by pushing j, I will keep on removing the characters that I found from missing and adding it to present. And when I lose it, I'll do the opposite. But there is a one edge case, which will be when we have characters which are not present in uh, yeah, when we have characters which are not present, or let me do it like this: E, D, D, E, 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 D. Suppose this is the word 2, this is the edge case. Here, this will be the maximum that I can push G, which is fine. At this point, my present will be D2, uh, E2, right? Actually, not even E2, E1, because my missing will only contain the one that are present in word 2. So there are no two E's in word 2, right? So my missing won't have two E's. So that's a problem, because if I lose this E and my J is still here, which means I am losing this E to missing, right? Missing was empty at this point. I'm losing a E. I don't have any E. But there is a E which I can further lose, right? So there should be another extra that I can have, which keeps track of the ones which are not present in missing and present frequency, which means E1 here, this was here. Since my missing is empty at this point, my pointers are here by the way. So if I'm losing E, I will check before putting it in missing and removing it from present. I will check if there is any extra E that I can use here. Well, there is. So I can use that here. I won't remove it from present. I'll change my pointer and I will increase my answer by this much. Otherwise, I would have lost this frequency if I don't have extra. That's why we want missing, present and extra frequency, and that's how we are going to solve this. Char comma int missing missing, present, extra. uh, Initially my missing will contain all the frequency of word 2. My window will be I0 J0 while I is less than M minus N. What is M? What is N? Well, M is word 1 dot length, N is word 2 dot length, and I'm doing M minus 1 because M minus N because I in my window definitely need at least N characters for it to be valid, right? That's why. At this point, I will check while J is less than N. I'll push J, right, as much as I can. So I'll check if missing, or let me increase J. Before increasing J, this J needs to be added inside my present, right? So if it is present in missing, only then I will add it to present, not equal to missing dot end. If it is present in missing, then I will remove it from missing. I will add it in present. Uh, Add it in present. If missing of word 1 of J is equal to 0, then I will remove it from the map itself. Alright. That's pretty much it. At any point if missing dot empty, if this is true, then I will break here itself because I don't have anything in missing, right? So I can't really push J any further. So at this point, if missing dot empty is empty, so this means that I have used all the frequencies. I can indeed add it to my answer, which is J minus M minus G. Alright, at this point I will check if at this point now I am to lose I, right? Before losing I will check if it is present in present frequency. Find if it is present, then I will check if it is present in extra. If it is present in extra, then I will just remove it from extra and do nothing else. I will check if it is completely absent from extra. Then I will erase it from extra. Alright. Otherwise, I will do the same thing, remove it from missing and add it or sorry, add it to missing and remove it from present. So present of word one of I, sorry, my so remove it from present. It's getting a little confusing. It's about to get over. Let's do a few more minutes of code. This is what we'll do, and finally return answer. But I need to increase I. I will increase it here. Last thing is uh, this will this condition will keep track till this point. But what if J is here? Then I will miss some scenarios, right? So I should not miss it and do it like this and keep track of I. I should be less than, actually this is fine. Since this will be always less than M because N will be always greater than 0. So this is fine. I don't have to check for out of bound scenarios in anywhere. Let's see if this works. Okay, I don't have answer. Initialize answer here. Also make this or this fine. Let's see. Present dot find should be in round braces. Okay, there's some problem. Also, few mistakes that I made here is when I'm pushing J, I'm pushing J over M length, not N. Here, also when I'm pushing J, if word one of J is not really part of missing, then I will add it to extra, right? That I missed extra of word one of J plus plus. And finally, here it should be a plus one M minus J plus one. Reason being suppose this is the string for which I'm pushing J till here. Index is 0, 1, 2, 3, 4, 5, and m is 6. So all the substrings that are possible here is 1, 2, 3, 4. So that's nothing but m minus j, that is 3, plus 1, which is 4. So it should be a plus 1 here. I guess this is it. Let's see if this works now. Time complexity will be O of n. Space complexity will be O of actually time complexity will be O of n plus m. This is another iteration that I missed. Uh, and space will be O of n plus 1 again. This is the fourth problem.